Hey, Realized Math and History, and we are going to take a look at stoichiometry 3, and we're going to look at mole to mass. So in the last video, we've been looking at the same idea and solved a similar kind of problem, but it was mole to mole. So there's another way of doing it when we have these kind of problems, mole to mass. The big question is, what is the missing piece that is keeping the reaction from performing itself and from the reaction happening? So let's see what happens. Here we have a problem. Determine the mass in grams of NH3, that's ammonium, that can form in 2.5 moles of nitrogen with 2 as its subscript, 2 as in atoms. And here is the balanced equation below. But how are we going to solve that? Well, 1, this is not a mole-to-mole problem, because what we're trying to figure out is how much mass NH3 or ammonium would be if it formed in 2.5 moles of nitrogen. So the mass of ammonium is the thing that's missing. So from the last video, we took a look at mole to mole. We did this, multiply that by this right here. We would have the ratios between the known right here, the element that's known, and the element that's compared to, then that is how many moles. But for this part, we are doing problem type number 2. Mole to mass or mass to mole. So what we're going to do is have what we have right here, what we already know, multiply that by the ratios of the two different elements that we're comparing. We are comparing ammonium and also nitrogen. And we have to then multiply that by a molar mass conversion, and that's going to equal how much ammonium is going to be by mass in grams. So let's get started. So the problem already says that nitrogen is going to have 2.5 moles of the equation. So we're going to put 2.50 moles because that is what we already know. This is that part right there. The next thing is we have to then multiply by the ratios between ammonium and nitrogen. If you take a look here, the full compound of ammonium has a coefficient of 2. And for nitrogen, we are going to have a coefficient of an invisible 1. If it's 1, you don't need to write it because it's literally counted as 1 for itself. So it 1, 1. Get it? It 1, 1, 1. So we're going to say 2 moles of NH3 divided by 1 mole of nitrogen with a subscript of 2. Then we have to multiply again by, we're kind of stuck because we need grams per mole of NH3. This is why this has to include, just like the beginning of the last video, we have to find the molar mass of NH3 by itself. Okay, so here's another problem that we have to solve. So we have NH3. We already have one N, so we multiply by 1. And H, we have to multiply by 3. Now for the molar mass. Nitrogen is going to be 14.00 for the atomic mass. And hydrogen is going to be 1.007. I was saying, if I had 1 mole of hydrogen, it would feel like, and it would have a mass of this many grams. If I had 1 mole of nitrogen, it would feel like and have this many grams in mass. Remember, 1 mole is equal to 6.02 times 10 to the power of 24. If you calculate that on a calculator, it would be 6.02 second E 24. Now, 1 times 14 is going to be 14.00. 3 times 1.007 is going to be 3.021. Add them up, and we got a final answer of 17.021. But that's not the final answer to this part. We only found the final answer to the molar mass of ammonium by itself. So that is going to be grams per mole. So if I had 1 mole of NH3 ammonium, it would feel like, and it would have a mass of 17.021 grams per mole. So what we can do on the problem is write grams 17.02 and write 1 mole on the bottom. The reason why we placed it like that is because we already have moles right here on NH3. And this is 1 mole of NH3. So the only way to get rid of the measurements and only get numbers as our answer, we have to cancel these out. Now we have to do the final math. We got what we need. We have moles, our ratios between the two elements, and also the molar mass of a single mole of one compound, and that's going to get us our grams. How much the NH3 is going to feel and by mass to make this equation true, and also to make the reaction react and make it happen. So when you do this, times that, divided by that, you're going to get a final answer of 85.2 grams. What that's saying is, for this reaction to happen, and for this balanced equation to happen, NH3 would have to have a mass of 82.2 grams in order for it to form into 2.50 moles of N2. Nitrogen subscript 2. Nitrogen with 2 atoms. And that is how we can understand stoichiometry number 3, moles to mass. We can also reverse the effect if we have grams and we need to find the moles instead. What we'd have to do is pretty much do the opposite. We would use the molar mass first for this one, multiply that by the ratios of the different elements. Then it will bring you to your moles. So it's the opposite way of doing that one. Thank you for watching Tao Ping and Life's Math Industry. Like and subscribe. And I hope this video has helped you learn about stoichiometry 3, mole to mass.